For this problem, we are going to solve the equation sine of 4x minus cosine of 2x equals 0 if x is greater than or equal to 0, less than 2 pi. The interval for the x indicate that x must be in the radian form. From what we have sine of 4x and cosine of 2x. The relationship of the 4x and 2x, we can rewrite it as 4x is 2 times 2x. Now the equation becomes sine of 2 times 2x minus cosine of 2x equals 0. We're going to let a equal 2x, as we see the 2x here as the quantity a. The equation becomes sine of 2a minus cosine of a equals 0. This way we make the problem less complicated. The sine of 2a, that is the sine of the double angle. Put a note here. We're going to use the identity that the sine of double angle is 2 times sine angle A times cosine of angle A. So we're going to replace sine of 2a as 2 times sine A times cosine A and subtract by the cosine A equals 0. At this point, we can see that the expression on the left-hand side has the common factor cosine A. We're going to factor the cosine A out to get cosine A times 2 times sine A minus 1 equals 0. Then we can use the zero product property to solve for each factor. The first factor, we have cosine A equals 0. The second one will give us 2 times sine A minus 1 equals 0. And solve a little bit more, we have sine A equals 1 over 2. And look at the first one, the cosine A equals 0. Use the unit circle. The cosine is the first coordinate of the order pair and it is 0. The period of the cosine, I'm going to put a note here, the period of the cosine 2a is 3, this is about the radian, going to be 2 pi. And similar to the period of the sine is also 2 pi. So we're going to start with finding the solution in form of the A. So A will be, since A, the cosine is the first coordinate. If the first coordinate is 0, we have an angle in radian as pi over 2 and 3 pi over 2. So A is pi over 2 and 3 pi over 2. And we call A is 2x. Replace A with the 2x. For the all solution form, we're going to add by multiple of 2 pi. And divide all by 2. We have x equals pi over 4 plus pi times k as the general solution or all solution form. And also x equals 3 pi over 4 plus pi times k as another set of all solution form. And then the next equation here, we have sine A equals 1 over 2. That means A equals, recall the sine is the second coordinate of the order pair. If the value is 1/2, it's going to be in the first quadrant and also the second quadrant. So 1/2 an angle is pi over 6. And the other one is 5 pi over 6 in the second quadrant. So we have A equals pi over 6 and also 5 pi over 6. Recall A is 2x and the period is 2 pi. We're going to add its solution by the multiple of the 2 pi. Next, solve for x. Divide all by 2. We have x equals pi over 12 plus pi times k. So we gain another all solution form of this equation. And the other one is x equals 5 pi over 12 plus pi times k as another solution form. In this problem, we need the solution between 0 and 2 pi. That means we're gonna have to do just the 2 cycle, because as you notice the term here, that's multiple of the k of the pi. So we need 2 cycle. So put the note here, we're gonna need 2 cycles. That means k gonna be 0 and k equals 1 will be used to find the 2 cycle solutions. So starting with the first one, for k equals 0, and the second one, k equals 1 for the second cycle. For the first cycle, the x solution gonna be pi over 4, 3 pi over 4, and pi over 12, 5 pi over 12. And then the next cycle, gonna add each one of them by pi. 3 pi over 4 added by pi, and pi over 12 plus pi, 5 pi over 12 plus another pi. So we're gonna get the set of solution as x equals 5 pi over 4 for the first one. And then the next gonna be 7 pi over 4. And then gonna be 13 pi over 4. And the last one gonna be 17 pi over 12. Now we have 8 solutions that satisfy this equation.